Hey guys, this is the practice for the final exam for Math 2144. Starting off with number 1, we have a piecewise function that's centered around 1, and we want to try to figure out if the following statements are true about this function, right? And so we want to know if the limit exists, if it's differentiable, if the value exists, or if it's continuous, right? So right off the bat, I know that the value exists because if I plug in 1, we get 2, right? That's the x equals 1 part. And so I know that I can check off that one. Next, we need to figure out if it's differentiable, continuous, and if the limit exists, right? And so for those things, I think continuous is the first natural progression, right? Because if it's continuous, then we can differentiate it. And we know if it's continuous, then we also know that the limit exists, right? So for it to be continuous, what we would need is we need some curve where the we have the limit on both the left and the right side, right? So I have some curve, and then say we're looking at this point, right? We need the limit on both the left side and the right side to be the same, and those two things to be the same as the value at that point, right? And so in this case, we're looking at x equals 1, right? So at x equals 1, we have a value of 2, right? So f of 1 is 2. We also know that whenever we are going in from the left side, if I plug in 1, we get 1 squared is 1 times 3 minus 4, so it's negative 1, right? And so immediately I can say, okay, the left side is not matching up with the actual value, right? And then the actual value isn't matching up with the right side either because the value, whenever I plug in 1 on the right side is 1 times 6 is 6, minus 7 is negative 1, right? So what's happening is the left and the right side are matching up, but the actual value at that point is not, so that I can't call it continuous, right? And so if it's not continuous, then we also know that it's not differentiable, right? But does the limit exist? For the limit to exist, all I need is just the left and the right side to match, right? The actual value at that point doesn't really matter if we're just trying to find the limit, right? And in this case, it does, right? Because on the left and the right side, when I plug in 1, I get negative 1 as the value, right? So I can say to myself, okay, the limit exists, but it's not differentiable and it's not continuous. So that's number 1. For number 2, we are looking at a integral, and they want to know what is equal to that integral, right? So this is a u substitution question, and so the obvious substitution is to say u is equal to sine of x, right? So that means that du is equal to cosine of du. So whenever we replace these substitutions into our integral, what we're given is the integral of just e to the u du. Okay, and so another thing that we need to watch out for is we're not done yet because we have to also look at our bounds, right? Right now our bounds are in terms of x. We need to switch them to in terms of u, right? So that's just as simple as plugging in the 0 and the power of 2 into as x into this equation. So whenever I plug 0 into sine, it's 0. So my bottom bound is still 0. When I plug pi over 2 into sine of x, we are given 1, right? So that means that our bounds are now changed to 0 to 1. So we can say our answer is this third one. Okay, so moving on to number 3. Here we have a f double prime that we are told is less than 0 for all x between 2 and 7. We also have a line that is tangent to the graph at 2, right? So if we look at what this means, right? F double prime of less than 0, what does that mean? That means we're concave down, right? So if I look at a possibility of what that could look like for concave down, right? There's really only 2 ways this could go. We could be going like this, concave down that way. Or we could be going concave down in terms of it's increasing, but we are decreasing in slope, right? So that would be concave down also. And so in either of these cases, we need to figure out which of the following we know is true, right? So we have a point at 2, right? And there's our line L, right? Same with this one. There's our line L, right? We don't actually know if the slope of L is positive or negative, all we know is that the slope of our original is concave down, right? And so it looks like a lot of the answer choices are based around L3, right? So if this is at point 2, right? And so we're looking at what is the case whenever we look one past that, right? And so let's ignore this first option because we will only go to that if the other ones don't work, right? Do we know L3 is equal to f of 3? Well, we know that's definitely not true, right? Because if we're concave down, then that means that this point and this point, here I'll change color. Well, we know that this point and this point aren't matching, right? So we know that one's not the case. Do we know L3 is less than f of 3 or L3 is greater than f of 3? Well, so if we look at our pattern here, in both of these cases, we actually have f of 3 below L3 in both cases, right? So if it's concave down, right, no matter which way it's coming concave down, if it's increasing or decreasing, we know that our f of 3 will actually be less than our L3, right? And so I think that's going to be our answer for this question. Okay, so moving on to number 4, we want to figure out which of these graphs and corresponding equations for lines would be the same thing as pi times the integral from 1 to 2 of f of x minus g of x squared dx, right? And so these are the volumes generated by revolving around the bound areas, right? So in most of these, the revolve is around the x-axis, which would be correct, right? So I can immediately get rid of number 4 because we aren't that one is not being revolved around the x-axis, right? And so the bounds would not be from 0 to 1 if that were the case, right? Because we, of course, have a dx, right? So that one, number 4, goes away immediately, right? We can also get rid of number 3, right? Because in our equation, f of x minus g of x is already squared, right? And so that one's no good either because you wouldn't need the squared in the equation and in the formula for... because then you'll get to the 4th power, which is no good. Okay, so our last two options are we have f of x and g of x separated off the axis, right? And then we have a y equals f of x minus g of x that's just rotated around the x-axis, right? So which of these are right if both of them, right? So looking at this first one, if we have an f of x and then a g of x separately, right? And we were trying to find the area between them, right? What would actually happen we would do these separately, right? We'd have the integral of pi and then f of x squared and then minus the integral of pi g of x squared, right? So what would happen is, notice how those f of x and g of x's are squared individually, right? And in our case, that's not the case, right? We don't have them squared individually. So this one is also a no-go, right? Which means our last option is going to be 2. We can go ahead and check it. F of x minus g of x, what we do is we would take that, we'd plug it in, we get the integral of pi and then f of x minus g of x, and then all of that squared. So we are right. That's going to be an answer. So our answer is 2 only. Okay, so for question 5, we're told that f of x varies at a constant rate of 4 with respect to x. So what does that mean? That immediately tells me that f of x is a line, right, and its slope is 4, right, because it's varying at a constant rate of 4, right? So I know that f of x is equal to 4x plus some b, right? Okay, then what we need to do is take this integral here and just work it out, right? So we're told that the integral from f of x to f of x plus 2 is, and we got 10 dt, okay? So working out this integral, this is pretty easy. It's just going to be 10t solved from f of x to f of x plus 2. Okay, so we can go ahead and plug those in for t. We'll have 10 times f of x plus 2 minus 10 f of x. So let's go ahead and take what we have for f of x. Even though we don't have everything, we can go ahead and take it and plug it in, right? And so this will be 10 times f of x plus 2. We'll have the x plus 2 plugged in there, right? And so it'll be 10 times 4x plus 8 plus b, right? And that'll be minus 10 4x plus b, okay? So something that we can notice is the 10 times 4x and the 10 times b will immediately go away, right? So the 4x and the b go away on both sides, right? So all that we're left with is 10 times 8. Our answer is 80. All right, moving on. We got question number 6. This one we have to find a bunch of values based on this graph, okay? So let's just go through each one at a time. We have the limit as x approaches -3. Okay, so let's find -3. That limit will not exist, right? Because we have the left and the right side not meeting at the same location, right? And so for a limit to exist, we need them both to be at the same spot. So that means this one is D and E. Okay. Next, we have the second derivative of x at -4.7. Okay. So -4.7 is like right here, right? And we want to know the second derivative, right? Okay, well, I know the first derivative is the slope, right? And that is a line, right? And so since it's a line, the slope is constant, right? So if the slope is constant, then that means that the rate at which slope is changing, which is your second derivative, will be 0, right? So this value actually will be 0 because the slope is constant, and the second derivative is always the rate at which your slope is changing. If it's a curvy line, then it's a different story. But if it's a straight line, then your second derivative will always be 0. Okay. The next one, we have the integral from -4 to -1 of f of x d of x. So let's take a look at what that would look like. We would have something that would fill in all of this area, right? And then all of this area. Okay, so this one's actually not too bad because we can just work it out as if it's a geometry problem, right? So that first triangle has a bottom width of 1 and a height of 4, right? So 1 times 4 times 1/2 is going to be 2, right? So the area of that triangle is 2, plus the area of this rectangle part, right? This part right here is going to be, it's 2 at the bottom and then 2 high, so that'll be 4, and so our answer to that one is going to be 6. Okay, next we want to find the first derivative, so f prime at -3.4. So -3.4 is about right here, okay? So f prime just means we want the slope at that point, right? So that's not too bad. All we can do is just pick 2 points along that line and find the slope, right? So I'm going to pick this point right here at the top in blue, and then this point right here at the origin, right? And so remember, slope is always equal to y2 minus y1 over x2 minus x1. And so our x2 minus x1 will be 1, right? And then our y2 minus y1 will have a difference of 4, right? And so what that's going to have is a slope of -4 positive 4 because we're going upward, okay? So your difference in y's over your difference in x's, we have 4 over 1, so that will be 4, okay? Next, we want to find the limit as x approaches 2 from the left side. Okay, so this is important. Make sure to notice the little minus sign next to the 2. All right, that says we want it from the left side, right? So here's 2 right here. I'll highlight it in green. We want it from the left side, so over this way, right? And so from the left side, it's coming in towards 1. So the answer for that one will be 1. Okay. The next part is we want the limit as the change in x approaches 0 for f of 1 plus delta x minus f of 1 over delta x, right? This one looks super complicated, but it's actually just the definition of a derivative, right? So as x approaches 0, that's as your distance in your change in x is getting smaller, right? And at whenever we're taking the derivative, we're imagining that the change in x is 0. So this is really just a derivative at 1, right? And so the derivative at 1 is 0 right here, because you can see that it is flat right there, okay? So the answer to this one is 0. All right, next one, f prime of -1. this one is, -1 is right here, right? And so f prime at -1 is actually not going to be possible to find because the left and the right side are not the same, right? We need the limit, we need the value to be continuous, right? So an easy way to know whether or not it exists is if there's some sort of angle, right, at the point that you're looking at, then it's not differentiable, right? Because we need the slope to be constant, right? The slope coming in from the left side and the slope coming in from the right side need to be the same, right? And so since this one has like a sharp angle, then it's not differentiable, so this one does not exist. Okay, so next we have the derivative from of the integral of -2 to 1 f of t dt. Okay, so don't let this one be overcomplicated. Okay, all I know is that's whatever the value of the integral from -2 to 1, right? So that's like the area under the curve for like this mess right here, all the way from here to here. We know that the area under that curve will be some number, right? Since it is some number, it's going to be a constant, and the derivative of a constant is always 0. So we know the answer to that one is 0, because the derivative of a constant is always 0. Next, we're trying to take the limit as n approaches infinity for a sum of f of something times 1 over n. Okay, this one also similarly to the one above it, it looks really complicated. But if you remember from your notes, this equation is very, very similar to the right-hand Riemann sum. And specifically, it's the Riemann sum from -2 to -1, right? And so you don't actually need to work out this long summation. If you know that this is the Riemann sum from -2 to 1, right, then we know that the area under that curve, right, from -2 to 1 is just a value of 2. And so I can go ahead and say that the answer is 2. Okay, so next we have to identify a value c that's on the interval of -5 to 5, so the entire graph, such that it's discontinuous at its value, right, but the limit exists, right? So the limit exists means that both sides of the left and the right side, it's going to the same spot, right? But at the point itself, it's discontinuous, right? And so what you want to find is something that the line will meet at the same point on both sides, but the actual value itself is somewhere else, right? So my eyes immediately go to 3 here, right? Because it's not continuous at 3 because the actual value at 3 is unknown, way down here at -3, right? But on the left and right side, it's going to the same point, right? And so we can say our answer to that one that satisfies those conditions would be 3. Okay, so question number 8, we have the amount of a medication in person's bloodstream changes at a rate of h of t and in t hours after injecting a 500 milligram medication into the bloodstream. What is the amount of medication in the person's bloodstream 3 hours after taking an initial dose? So the key to this one is noticing that the function they give you is a rate of change function, right? So it's how much this person's bloodstream changes, right? So if I just wanted to know how much it was changing after 3 hours, I would just plug in 3 for t. But that's not what we're doing. We want to know how much is in the person's bloodstream 3 hours after taking the dose, right? And so if it's a rate of change function and we want to go down a level of degree, right, we can just integrate. So we're going to take the integral of -700 e to the -1.4 t. We'll find what that equation is, and then we'll plug in 3 hours to figure out how much medication is in the person's bloodstream after 3 hours, right? So this is a pretty easy integral. We're going to say this is equal to -700 over -1.4 e to the -1.4 t. Okay, and then we're going to plug in a value of 3 into that. Whenever you do that, you will get an answer of 7.497. So 7.50. Okay, so for this next part, we have an oil tank that is leaking, and it's leaking at a rate of R of t gallons per hour, where t is measured in hours since the leak started. Okay, and then we are asked, what is the practical meaning of R prime of t whenever it's less than 0 for all t, right? So if R of t is the rate at which we are losing our oil, right? So we're losing oil like 5 gallons per hour or something like that, right? R prime of t would be how fast that's changing, right? And so if we're losing oil at 5 gallons per hour, and the next hour we're losing it at 6 gallons per hour, the rate is increasing at which we're losing our oil, right? And so R prime of t is the rate at which our oil rate is changing, right? So the practical meaning of R prime of less than 0 for all t is it's saying that the rate at which our oil is changing is going down, right? So at one point we are losing 5 gallons of oil per hour, and then the next hour we're losing 4, right? So the rate at which we're losing oil is going down. So what I'll say for this one is the rate at which oil leak is decreasing and it'll be measured in gallons per hour, right? So an easy way to remember that is, since we're taking the derivative each time with respect to t, if we're already gallons per hour, then we'll just put another per hour on there, because we're taking another derivative with respect to time. Okay, so the rate at which the oil leak is decreasing in gallons per hour. Okay. Okay, so this next part is pretty similar. We have the oil still leaks out at a rate of R of t gallons per hour, and we are asked what the practical meaning of the integral of R of t is, right? And so if it's already a rate, right, the integral will always be what the actual value is, right? And so if R of t is how much oil we're losing per hour, right, the integral of that is how much oil we have, right? So the practical meaning of this from 0 to 2 is how much oil do we have from 0 to 2 seconds, how much oil is there, and the value of that would be equal to 500, right? And so what I'll say is that is the total amount of oil that we lost over the first 2 hours. And that is equal to 500 gallons.